and welcome to this conference. I'm Toby T, the Interim Vice Provost for Academic Services at Oklahoma State University in Okmulgee, Oklahoma. I'm in our first interactive video classroom at the present time, videotaping this for you because I will be at another location next week. So I look forward to hearing the results of your conference. I wish I could be there. Distance education has been something I've been interested in for many years now and have had the advantage and the experience of being able to apply some of the things that you're going to be talking about here today, as I know many of you have had. I've got some slides that I want to show you, and I'll turn to those now. Basically, I'm going to try to compare distance education and the Learning College and describe to you how at Oklahoma State University, Okmulgee, we are trying to make the concept of the Learning College really apply, and we're going to do that. One of the big ways is through distance education. Many of you have studied for years the things that happen to a student in the classroom and using different theories of education. I did not list the many studies that are out there for that very reason. I know that you know more about them than I do. Personally, I was involved with a linear study that went on for about 6 years at another community college using primarily telecourses and broadcast television. Using those two methods, we learned that every semester, every student, every course that we taught showed either the equal or higher grade point averages for the students in courses like history compared to courses taught on campus in history. We also discovered that the retention rate for students in those courses taught by the non-traditional methods were as good or better in many cases than the retention rate of students in our traditional classroom courses. Whenever you look at studies on interactive computers, interactive video classrooms, all the other types, as you well know, they show many times that they're as good or better. Sometimes 2 or 3 times the learning goes on there. The other thing that I'm going to try to do today is to step you through what we use at OSU Okmulgee in our curriculum development process to show that tying what you do in distance education to a step-by-step process works very well. And I know the thing that you're thinking of probably right now is oh yeah, this is nothing new, I've heard this before, and that is the case. But if we look at a step-by-step process, if we look at our consistent philosophy of learning as this first step here shows, then we're all going to make mistakes and we're going to veer off that path every now and then. And when we do, if we have something in place, our philosophy, our method of doing things, then we can get right back on the track and not lose any more time than necessary. Where we are right now is that we continually focus on our mission and make sure that it's aligned with the real world. We do this in a lot of different ways, but we say that if we focus on the mission, base our curriculum on sound learning theory, develop students that learn to learn and learn to do at the same time, then we will provide the employee that the employer wants. We have many other methods of making sure that this happens, such as advisory committees and things throughout the campus that really help us do that. But it's important to us. As you will see here on this mission, we're fortunate in being the technical institute for the state of Oklahoma. That allows us to have a mission that's really focused in on developing those competitive members of the world-class workforce, and that's all that we do. The next part of that first step of curriculum development that we mentioned was making sure that our philosophy of learning is aligned with our mission statement, and then that we transfer that to our students. We have done a lot of studying in the last several years, and in fact in our strategic plan back in 1993, we determined at that point in time that we wanted to be a learning organization. And now we've moved one step higher, I think, in the fact that we've decided to be a learning college. Harry O'Banion talks about this a lot in his book on that particular thing, the Learning College for the 21st Century. And here's some things that he says about that. Reason it's taken us this long to get where we are now, and really, he says that there's been no real educational reform, although we've spent billions of dollars, is that we haven't placed learning first. We have many traditional limits to learning. All of those, as we look at them closer, can be taken off or stripped away as a problem by distance education, and that's what we're here to talk about today. The biggest problem, he says, is the 70-year-old factory model grafted onto a 100-year-old agricultural model. That doesn't ring any bells, does it? We've tried to get rid of some of that situation there. We're in a 12-month year-round program here at OSU Okmulgee, but across the country, you know that many educational institutions are basically 9 months, and that's part of what he's talking about here. As you read further into his book or attend one of his many conferences where he lectures about this concept, here's some of the things that he'll say. Learning must be learner-centered, not content-centered, although if you'll read a little further into his book, and also the one that I'm going to mention soon that Dale Parnell has written, content is important, knowledge is important, but it's not what we're focusing on. And this is another part of what Dale Parnell says, that learning should be contextual. I think we do a good job of that here at OSU Okmulgee, since most of the programs that we teach have heavy lab-oriented classes with a lot of hands-on. The part where we need the most help, and that's one of the reasons that we have representatives working with this conference, is that the anyway, anywhere, anytime thing that he mentioned is something that we're really focusing on in the next few years, and in order to make sure that we provide more opportunities for students to learn. This was brought out recently in a speech. Let me get to the right camera here. In a speech by President Reagan, whenever he was giving his State of the Union address, he talked about, and we were real pleased with this here at our campus, the fact that education should expect all the people in this country to regard the 13th and 14th year of higher education just as they do a high school diploma at this time. Well, if that's the case, access is going to be another barrier or obstacle to the people that are trying to get their education. So this is what we're talking about here with this anywhere, anytime thing. We've just got to do it. Just in time, we need to know where the student is and provide the learning whenever they're ready for it. O'Banion has some key principles that he talks about in his book and on the lecture circuit that he goes. Most of them you're familiar with, but I'll just briefly step through them here. Learning must cause change in the learner for it to be real learning. Learners must be engaged in as full partners. We must create and offer as many opportunities for learning as possible, and that's what we're the best at in distance education. And then we use the learners to tell us what kind of role we need to play according to their learning style and their needs. And then we succeed when learning can be documented. Another person that I've read, that many of you have, I'm sure, is David Bolton. And in one of his articles, I like this statement that I have here on the screen for you. We need to move toward becoming learners rather than becoming just knowers. And of course, you know what he's getting at there, memorization and so forth, that we're also good at now. Dale Parnell, in his book called Why Do I Have to Learn This? And in an article talking about that book, says this: for teaching to be truly effective, the student must be motivated to connect the content of the knowledge with the context of application. And this is where we get the problem-solving concept that we like so well at our university. A little more on the anyway, anytime, anywhere theory. We're going to talk a little bit more about this later, but we have one interactive video classroom here that you see now. ready to go, and we're getting 3 under construction right now that will be ready by the spring 1998 session. Assessment is the key to finding out where the student is. We require all new students to take the vocational learning styles inventory so we can help the instructors figure out what type of strategies need to be used with those particular students. We also give other tests that place them in reading courses, mathematical skills, writing, all types of things that is important. Just attended a meeting this past spring that North Central Accreditation Association puts on, and one of their strong points there is that we want to see what you're really doing whenever we come out to visit, and not just see your plan. What do you actually have in place that you're using, both assessing the student and then assessment of the institution? Well, as far as we're concerned, competency-based education fits in real well here, and we're trying to move all of our programs rapidly to the point where they have a good understanding of competency-based and how it works with their program. So now that pretty well wraps up how we feel about our philosophy of learning at Oklahoma State University at Okmulgee. We think it's in place. We know our mission's there. Now we began, after we got that down pat, we began looking at our curriculum scheme, which includes both our principles and our learning models that we're going to adopt here. Again, we go back to Dale Parnell's book on why do I have to learn that, and he has 7 very good principles that most of them you have seen before, but they seem to all fit real well with the learning college concept and what we're trying to do, particularly well with distance learning. As we go about our business here, primary need for us is to provide workforce training, and we need to do that in ways that the workforce can access, and it's going to have to include distance learning. Now, how do you do some of the laboratory experiments and the exercises and other things that you do there? That's the things that we're looking at right now and trying to solve. There should be many ways to do that if we just put our thinking caps on. Any ideas that you have, we would be glad to hear them. The model that we've settled on takes into account many of the models that are out there right now that you're very accustomed to, but I think our model expands the concept of learning one step further. The first model that is used quite often in curriculum courses is the cyclical model of curriculum instruction. The fact that it's not linear, you have to continuously change, improve, evaluate, and implement. A very good model. A newer one here, as you see down at the bottom of the screen there, published in 1996, begins to make us think about moving the student from out there somewhere in the peripheral to the center of the cycle here. And this model does that very well. The only thing that we don't particularly care for it at our campus is the fact that it just puts the professor out here as one of the many ways that a student can learn. And we realize there's many ways to learn, but we think the faculty has a more active role than is shown with this model. In fact, in moving from that teacher-centered to learner-centered mode, we think of it as putting the learner in the driver's seat. And one of the concepts that we use here is the Global Positioning System, or GPS, as you may have heard, that's used now in some of the, I think Lincoln, one of the Lincoln's cars has it in there. Some of the rental car agencies use it. Trucking firms use it very often. It's a system that was used in the Desert Storm War by the Army to a very good advantage. So that's what we say. The learners in the driver's seat, they get to help control and direct their learning activities. This puts learning then in the center of the universe rather than the student or any particular person at our campus. And this works well for us. And as I mentioned earlier, the faculty team that helps plan the learning that goes on our campus is very important, although we do want them to consider many things, the students' life experiences, what they've done in the past, all kinds of things that would go into their learning plan. In the total picture then, we have the global learning system, as we call it. In business terms, it's what's known as the system of systems, because as you see there are many systems involved in getting this job done. But it puts the learner in the driver's seat, interacting with the faculty, determining what is the best learning plan for that individual in the years to come. We're making that change as rapidly as we can. We feel like we were a very good teaching college. We think our strong suit is teaching students learning to do, how to do things, and how to go out there and apply it to the real world. We want them, though, to become lifelong learners and people that continue to learn throughout their careers and throughout their lives. And to do that, we feel like we need to be a learning college. And we want to do that by the year 2000, if at all possible. That sounds like a good round number. And we're well on our way toward that possibility. We think at OSU Okmulgee that the how of getting that done is going to depend a lot on distance education. And we've spent a lot of time and a lot of money in the last couple of 3 years getting us to the point where we can really do something for the students out there that we need, both workforce and our own campus students, using distance learning. And in the case of distance, in our case, that means that the teacher is not always just in front of the students. They may actually be on campus, but they're still using these techniques of distance learning. So now we're down to step 3 in curriculum development, determine the educational task. As I've kind of alluded a time or two, our goal here is to use distance education a lot to expand our workforce training. We do quite a bit already, but we would like to do more. In any educational task, I think the question is, what does this person, whether a technician, a professional, what do they do? And in our case, our campus has said many years ago that we would produce people that were productive citizens, community leaders, competitive members of the workforce, and lifelong learners. So what does that mean? If you're one of those, what do you do? And then we go about determining the competencies needed for that using primarily a modified DACM process with outside technical experts or advisory committees and other people here on campus. We research what's out there and find out what competencies should be included in that program. Another process that we're involved with in designing the curriculum and in developing it and actually implementing it, we want to automate everything that we can for the faculty. And here's just a good example on this one under writing objectives. Most of you have probably had the wonderful opportunity to write objectives for your classes before. It's a pretty tedious process, and it really requires a lot of thinking. We've discovered a software out there called the Syllabus Mentor that'll help us do that. That's just one example. There's many other software available that will help, but the key is making it easier for us to do and automating it every way we can. On developing the curriculum, the learning college concept is easy to say, is easy to talk about, and it's difficult to design. And so we have been fortunate on our campus to have received a fairly large grant from the National Science Foundation for the Distinctive Manufacturing Program. And they're going to pilot the main program to determine how to develop these learning plans and individualize the instruction and automate it and figure out ways to do the things that we talked about earlier that's required of a learning college. Then we intend to disseminate that information to all of the departments and programs here on campus. Now that doesn't mean we're not trying to implement the concepts throughout the entire campus right now, but this just means we think this group will let us move a lot faster and learn more than we could do at the same time as we're trying to teach classes. Here again, I put this one up, implementing the curriculum or actually teaching the classes, providing the learning activities, every way that we can think of to involve more technology with that concept and provide greater learning opportunities for our students. We're going to. Might give an example there. Just today we met with a group to talk about designing the course for our new faculty that will arrive on campus August 21st, I believe it is. How are we going to model this concept of the Learning College? How will we model the concept of the Learning College for these new faculty that we've been talking about here all afternoon? And a point came up. Someone needs to, has as one of their points on their learning plan to learn how to use the internet. Well, you can think right off the bat, 3 or 4 different ways to learn how to use the internet. One of them came up with a conference that will be going on that week in Tulsa. It's $59, 8 hours long. We could send those new faculty, the ones that needed it, not all of them, up there to that conference and use outside people to teach our instructors how to use that internet. We have a couple of instructors on campus that are offering a course this fall, three nights. I think it's on Thursday evening. $30. We could do that and use that for the instructors. Or another method could be that we have an interactive computer application over in the Student Learning Center, and the instructors could go there and learn how to use the internet on their own, using the equipment live and in place that we have there now. So there's at least 3 methods of learning how to use the internet, and we're going to try to do that with everything that we can. I think I've mentioned the assessment plan here, but we must continue to assess what we're doing and make sure that it's actually improving learning for our students. If it doesn't, then we don't have time or money to waste on it. Where to next? I alluded to this a little earlier today, but we're moving just as quickly as we can to get on the bandwagon of distance education or distance learning here at OSU Okmulgee. We've had this interactive video classroom that you see here today. It's a compressed video. We've had it online or ready to hook online, and we're waiting for OneNet to get us ready. I think we have one more piece of equipment that will be here next week, and then we'll be truly online. We're really excited about that. We have 3 more video classrooms under construction in a new Don Reynolds technology building that was provided through grants. All 3 of those are going to have the latest equipment. They'll be full motion video. One of those labs is a major, large, spacious laboratory that has a big door in it. And we'll be able to haul in equipment, do anything in there that we can possibly think of, and we think that's going to be real valuable for our workforce training that we're wanting to do. We have just completed fiber optics backbone on campus. Had a report from a few people that have already got their networks hooked up to it, and it's just amazing the amount of speed and capability that this is going to provide, and they're already bragging about it. We should have most everyone hooked up sometime this fall. Our Vice Provost for Business Services has been working on the new phone system. We'll be ready to go out for bids. If you noticed on that slide that I showed you that had the truck on it, down at the bottom, and I may have flashed past it so quickly that you didn't see it, it said support is the key. You can train your faculty, you can provide all the equipment in the world for them to use in the classroom and in the lab, but if you don't provide the proper support for them, they're going to have difficulty really making the connection with the student that they need to make. The new phone system is one method of doing that. It'll have a voicemail capability and many other things that we need for our students. Of course, now those fiber optics backbone will allow us to hook up to internet in every classroom and every office, and the internet is a good way to stay in touch with the students. One of our teachers offered an asynchronous course in information technology here on campus this summer, and for his first time, he said that the interactivity with the students had been greater with this asynchronous method of teaching than he had ever had it in a live classroom. And so I think we're going to find that how will the faculty manage all of these connections they're going to have with the students? That's going to be the difficulty. The new phone system will just be one more way of helping us do that. So in closing, I've been real pleased to have been asked to talk to you about distance education, distance learning, as we call it here on our campus, and what we call the global learning system. Becoming a learning college is real important to us. We're firm believers that all those things that we do to progress that way will do nothing but help our students and make us more accessible to them. And as we talked earlier, if we're really going to do what President Clinton said about moving toward having everyone have that 13th and 14th year, then we're going to have to make ourselves more accessible. We're not going to build more community colleges like we did in the 60s. We're basically, I think, where we are in this country with the facilities process. So now how do we go about providing ways for people to get education and get it when they want it, whether it be at midnight, 2 o'clock in the morning, or at 7 o'clock. And that's what we're all about here, trying to provide those ways to do that. Thank you very much, and I'd be pleased to visit with you anytime, either over email or by phone. Call if you get time. Thank you. Well, how long did that take?
I want to thank you all for listening to what I have to say today. My name is Alan South, and I work here at OSU Okmulgee Tech in Okmulgee, Oklahoma. I work in the electronics department here. I've been employed for about 17 years. And I teach classes in our department in the earlier semesters of our department. I have taught the following classes: DC, AC, computer software applications using Microsoft Office 95, taught power supplies and amplifiers, a class we've taught on digital basics, and another class dealing with programming, basic programming for students across the campus who are not in electronics, called microprocessor applications, and we teach the students there how to use how the computer can be used to control real-world devices. So we actually connect up the computer in that class to some sample circuits, you might call them, and then by programming we control those little sample circuits. So these are some of the classes that I've taught in these 17 years here, and one of the things that I have had become very clear to me is that the key to learning is to actually make the students see and understand the material being taught. Our subject matter in my classes deal with theory and with lab. The subjects that we teach can have several things happening all at one time. These are things the students need to be able to see are going on at one time. We also have, in these subjects and devices that they work on, and are learning on, we need to teach the students how to make measurements. Some of these measurements must be made in specific sequences or orders. Also, calculations that go along with the type of circuitry that they're learning or the type of devices they're working with. These, at times, need to be made in specific sequences or steps in order to arrive at the proper answers. So I say again, to me, it is very clear that for the student to learn what we're trying to teach, we must make our presentation of the material in such a way that the students really can see and understand what's being taught. In order to do this, some years ago, I had an opportunity, after buying a computer that had Microsoft Office loaded on it, I had an opportunity to begin to use the program PowerPoint to draw pictures that I previously had drawn on the blackboard. On the blackboard, they didn't look that good. I had to do it every semester. When I began to use PowerPoint, I was able to use color. I was able to make drawings that really looked like what it was that I was actually working with. And I was able to save those from semester to semester, then to edit them, update them. And so I began using that and found, at least to my way of thinking, that this was a lot better way of making the student able to see than what I had been doing just by using the blackboard. I also used the program Excel, and that was an evolving thing. I used it in the beginning just to show simple calculations that went along with what we teach. And after a while, I began to use it to show maybe many things taking place at one time in what we teach mathematically. And also, we found a company who made a software package that deals with electronics called Electronics Workbench. We'll talk a little bit more about that later. I also found that if I could bring a camera, a video camera, into my classroom, I could actually show the students on a television set what I was doing at the front of the room more clearly than just letting them see from their seats what I was doing. So I began to utilize PowerPoint, Excel, Workbench, and the video camera with the television in my classroom. I found that the television did not give good resolution, so later on I ordered, and I thank my department head for buying it, but I ordered a monitor, a 29-inch VGA compatible monitor, so that exactly what was seen on my computer is what the student would see on the monitor. There was no loss of resolution, which was real important to some of the things that I was going to show. One of the things that I found also, that it took time to find this out, but because I was really sold on using the computer a whole lot instead of using the blackboard, but I did find out that, strangely enough, the blackboard still seems to be very, very useful at times. So reluctantly, I still go back to the blackboard and use it, and I still find the students are interested in what's on the blackboard, even though I have all of this equipment. I'd like to give you a demonstration of what I do in my classroom using PowerPoint. I use the Office 95 version of PowerPoint after I had used the previous version. The previous version did not have animation, and so when I got the new version that did have animation, it really pleased me to see what I could do, and after a lot of experimentation, I began to get things moving on the computer screen, and I thought it was pretty good. And I just love to work with this kind of thing, so I don't even know that I spend a lot of time on it. It just seems like a joy to actually be able to make things move that needed to move, and we couldn't move them on a blackboard. And now we're able to show the students, you put this here, and this will do this, and that will do that. So I'd like to show you a little bit of what I have. I have all of my syllabus on PowerPoint presentations. And this really saves me a lot of time when I get ready to teach. I just load up what I've already done. I need to add to it, I do. But I'm going to switch now over to the computer, and you'll be able to see a presentation that I do for my first semester class. This presentation is on resistors, and I'm teaching them some things, and you'll see what I'm teaching in just a moment. That's one of the beauties of this program. It lets you put everything on there. So at this time, I'd like to go to the computer, and you'll still hear my voice, but you'll see what's on the computer. I really like the animation feature. It allows me to tie together things that only motion can allow you to see. And it clarifies it for the students. One of the real beauties of PowerPoint is if you are showing something to the student and they did not get it the first time, you simply back up a page and re-show it. And you can show it over and over and over again. I believe in repetition as being the mother of learning. Let me begin by showing you my objective page. I'm going to move rather quickly through this, but this is something that the students would see right on the monitor in my classroom. I might add one more thing. We have an entire department called the Skills Center that's filled with computers that have Microsoft Office on those computers, and I am able to take the presentations that I give in the classroom and put them on the computer, the server in the Skills Center, and the students are able to access the very same presentation that I gave in the classroom. So this gives them an outside tutoring help that I like. Well, here we go. These are some of the objectives. This is what the students would see, and as we move through this, I begin the presentation with a definition of resistance and a definition of resistor. And I'm going to move on quickly. The drawings that you see in yellow, I drew those myself with PowerPoint. The background you see in green is part of the program. You just access it and set the background to this color or whatever color you choose. The text that's on here is also a part of the program. You write whatever you want to write, and you're able to place it wherever you want to place it on the particular slide you're working with. Here's some more information about being able to read the value of a resistor. And now we come to animation, and this is what I mean by tying together motion with text. And this allows the student to tie together the information I'm trying to present. In this particular case, we're teaching the student that the color bands that you saw flying across the screen and landing on this brown resistor body, those color bands tell you the value of that resistor in ohms, which is written on there. Another area is that third band over there tells you where the decimal point goes in this number. If the band is gold, why the decimal point moves to the left one place. If the band is silver, it moves to the left 2 places. If the band is brown, and we have an entire code system that goes from brown to white. If it's one of the colors between brown and white, then you see the decimal point moves to the right, and we're able just with the click of a button and the different colors that belong to the number of zeros you see appearing there, you're able to see the decimal move to the right. For the student to see the colors and the decimal move at one time, to me is a great advantage. This is something you cannot do on a blackboard. Also, this is the tolerance of the resistor. Here is a different type of resistor. This one has not 4 bands of color, but 5. But we're able very quickly with motion to tell you to omit the last band and to show you how to read the other colors. And also, we're able with text to tell you what kind of resistor this is. And several other things are on here. For example, over here on this side if you can see my mouse, you can see that I have my color bands, or excuse me, the values of the colors listed right here on the side of the screen. And the number being green here and the green color all goes together. The blue color and the blue number and the orange with the orange. You're able to color code things just how you want them. And over here, the word omit clearly says we don't even consider this band. The next slide shows something a little different. Our students are taught how to make measurements with a voltmeter. And here, by drawing a voltmeter and using animation, I'm able to show right where the meter would be placed on the resistor. And we have to be careful here how we place our meters. But this, as you saw with animation, you saw exactly where to put the meters, and we have text on here that says, again, where to put the meter, and the student with some teaching understands what we're talking about. We don't depend on this alone. Watch this, if you will. In this one, we show the closing of a switch in just a moment. There it went. And then we show that in order to make this measurement, you must disconnect a resistor. And then you must insert the meter in those positions, and now the current is flowing. This is something you cannot do on a blackboard. And this is the last type of measurement that our students are taught to make, and this one is called measuring resistance. Here, you see the switch is definitely off. You're able to time things in animation when they happen, and so you can step through what's to be done. And finally, we actually show the meter being connected right where it's supposed to be connected. This is pretty much how it would look in real life. Okay? This is a different shape of a resistor and a different type, and we're able to show that by the text carbon film and also how to read it. It's read the same way as the other one was. Here's another one. This is a different type resistor, but by drawing the shape, and we did draw these shapes with the drawing package that is in PowerPoint, you're able to see the shape of the resistor, kind of like a peanut. And the bands are located on here as you see. And down below, this is a metal film. And once again, the color bands are coordinated to show you what each band means in the number. And finally, the overall number is given and its tolerance. This is perhaps the last one I will show you. This is a typographical type of resistor code. And we can say that up here in the corner. Just make things appear when we want them to. And we can point out that when you see these numbers, and this is a real resistor's numbers, all of these designations are on real resistors. We can say this is the code, and these are not. And we can explain how the number of ohms is arrived at, okay, and the tolerance. And then finally, the form that we want it written in, which is called engineering notation with prefixes. I believe at this time we will stop on the presentation that you're looking at right here and move on to a different area. I need to change the computer for just a moment. And very quickly you see I can turn off PowerPoint and I come to another program entitled Microsoft Excel. And this program lets me use numbers. In electronics, there are quite a bit of calculations, and our students are taught to step through analyzing a circuit using calculations. And so I use the spreadsheet to step through it almost automatically. And so here I've placed a variable. This would be the total voltage applied to some kind of a circuit, and the circuit would be the kind you saw with resistors a few minutes ago. Here are the values of those resistors. Now all of these values I can change, any of them. And when I do change these values, you'll find that over here all of these values will several of these values will change. And I'm going to just change one of them right now so you can see what I'm talking about. But I teach my students that when you raise the voltage, that's V total, in a circuit, the current will rise, excuse me. When I hit enter, you should find that it did go up. If I lower the voltage, let's just make it a 100, you should find that all of these go down. And that was very obvious. Another area is if I want to put a malfunction in, I can just change one of the values. That's not a normal value, and when I put it in, you'll see that several changes take place, and we would teach the student what those changes were. And they would know that this particular resistor had shorted. I know the word okay is over there, but it doesn't mean much to us at this moment. This resistor has shorted out. If a resistor had burned in two, we could simulate that with this value. And when we do, we see that all the other resistors, they didn't change, but we can see that something happened here and here, and the student would be taught about that and what it was. And this would simulate an open. And one of the other things that we can do is if too much current flows through a resistor, here's what's called a wattage rating. If it gets too hot, if it gets hotter than these numbers say, that's what this is all about right here. This is an if statement, which simply is looking at that value versus that value. This resistor, when it's really working, will have a number there. If that number is higher than that number, something will happen right there. So we're going to make this a normal circuit. Okay? And once again, you see that the 20 is still there. That's the rating of it. But this number is higher than that. And with the use of an if statement, we said if this number is higher than that number, then tell us that that resistor has burnt up. And for resistor number 2, that was its rating, and here's his power. If his power is higher than that, say burnt. If not, say okay. Well, we can see that this number is lower than that number, and it says okay. Also, on this resistor, he has a 10 watt rating, but his value here is seen to be, this is again resistor number 3. His power rating while he's operating is 23 watts, but he can only handle 10 watts. So over here on his row, it says he has burnt up. These are things that I can show the student immediately. The words burnt and okay are something the student is very familiar with. They would understand that. It's a visual aid. So if my circuit isn't working right, I can have certain things in Excel that show that. Also, I'm able to put little tools on here that the student uses to make calculations. Some of you have seen these before, perhaps. They're called pie charts. And they allow a student to know how to calculate all these values. But in this particular chart, they're already automatically calculated. By coloring that cell gray, that one gray, and those 3 gray right there, I tell the student, you can change these, and they will affect everything else. Don't change any of the others over here. So I can also put this particular file over in the Skills Center, where we have Microsoft Office, Excel, and the students can go over and practice on this. And what I'd like you to see is that by changing one of these, the student is able to see immediately what happens in the whole circuit. I'll just make a slight change here. And they can change another one and see what happens in the whole circuit. They don't have to calculate it all with their calculator. This is done in my classroom, and we can put this in the Skills Center, and the student can also do it there on their own time, as often as it takes. Again, I believe in repetition, and if I can make them understand what I have on this screen, why then they can work with it and understand it. When they go to the Skills Center, by repetition, they can get understanding of what's going on. In And this seems to work well in my classroom. All right? My time is nearly up. There's another program that I use called Electronics Workbench. I don't have it on the computer to show you, but it is a program that will show you, comes packaged with an electronics laboratory. This laboratory is a software package, again, that allows a student to build the circuits. They will see many of the circuits they will see throughout the entire time they are here at OSU Okmulgee in our department. And they're able to build those circuits. They are able to test those circuits in that program. They're also able to put in malfunctions and troubleshoot in that program. They're able also to design circuits in that program. And so when they come back to our classroom, if we have given them the labs that they're supposed to do before they do them, they're able to go to this program, actually build that circuit, actually test it out, actually see all the values that should be there, print that out on the printer, come back to the lab for a real time of connecting up the components, building the circuit, testing the circuits. And when they get done with the testing, they can compare the test to the sheet that they came in with and see how close they came out. One of the things I really like about this is that the student knows up front what to expect when they go to lab. They don't walk in there saying, I do not know what's going on, but they actually have it in their hand. In my classroom, I also utilize something called the camera. Here I have an Elmo camera, and I'd like to just kind of show you some of what I can do with it. With this camera, and at this particular time, I'm showing you what we call a proto board. It's a board that allows us to assemble electronic circuits on the board. And I don't really have them assembled today, but I put them these items on here just so you could see it. But you're able to assemble circuits on this board here. And with the use of the camera, I'm able to come in and actually touch certain things and say, I want to tell you about this or this. With the camera, we're also able to zoom right in and say, now students, the number on this particular chip is 7400. I want you to get that out of your kit. The resistor I want you to get is brown, black, orange, and gold. And we want to use this dip switch with the 4 switches on it, and we can simply show the student exactly what we want on the overhead monitor, on the monitor, and this makes it easy for the instructor. If I wanted to talk about something that's kind of small, like these LEDs right here, I could lay it here under the monitor, or under the camera, and you can actually see some of the things that I would talk about inside of that LED. You can see how we wire up the board just a little bit by some of those little wires you see in the background. And so we use the overhead camera in our classroom, I have a camcorder is what I have in my classroom. Today I'm using an Elmo to demonstrate what I would do. And we can show the student exactly where to hook up their circuit until the time when they're supposed to be able to do this on their own. And I'll just make a few comments in closing. These holes that you see, the holes that you see present here, we can explain how they're connected. And across here, we can explain how they're connected because of the view. The ability to make the student see is uppermost in my mind. I feel like that's the biggest area of learning. Can the student actually see what I'm talking about? So all of these aids that we have spoken of today are there, and I take great joy in being able to use these because I feel like they really do give the student something they can really see. I hope I've said something that at least lets you know what I am doing in my classroom. In a little while, we are getting ready to do some more things by the medium by which we're now speaking, television. And we'll be using these very same tools that you saw today over the television. I believe we're talking compressed video, maybe one day it won't be compressed. Also, for those of you that have not seen this, on the internet, live streaming video is now being shown. It's not real good yet. It has some, it hangs up, it pauses a lot due to network congestion, but actual video is being shown on the internet right now. And we hope one day to connect up with Office 97 to the internet, which is a program that is definitely interactive on the internet, and do teaching that way also. Well, I appreciate your time. Thank you so much.